Hello and welcome back to another video. In this problem we're asked for what values of x is f continuous, where we have f of x is equal to 0 if x is rational and 1 if x is irrational. So what does it mean for the function f to be continuous at any point? Well, that means that the limit as x approaches some number, some value a of the function f of x is equal to the value of the function at that point, right? So if the value of the function at some point is, a has an x value corresponding with a y value, f of a, this is simply saying f is continuous at that point if as the function approaches this value, it's approaching it on the y-axis as well. And so if we are approaching any given number, well, we would need it to be either only rational numbers near f of x, near f of a rather, or only irrational numbers. So if f of a is, f of a is 0 if a is rational, right? Just using that from our definition of f of x. Therefore, we need the limit as x approaches a of the function to equal 0. This means as we're getting closer and closer to f of a, we need the function to be values of 0 or approaching values of 0, but since it can only be 0 or 1, that means it has to be values of 0. And basically what that means is if a is a rational number, we need all points near a on the number line to also be rational, because if any of them are irrational, then the function is equal to 1 at that point and it jumps up and it's not approaching it in any meaningful way. Now, rational numbers and irrational numbers are what's known as dents on the number line of real numbers. What does that mean? That means that they are infinitely numerated across the number line, and there are no points on the number line where we're going rational, irrational, rational, irrational, which doesn't really make sense to think about, but pretend it did. Rational, irrational, rational, irrational, rational, 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 rational. There's no point where there are going to be a bunch of numbers that are only rational, right? It doesn't even make sense to think about it in that way, but even if it was, we wouldn't have any points. So basically, if we could think about narrowing down to the smallest bit between real numbers, right, and we're jumping between rational and irrationals, the function would just look like this, jumping between 0 and 1. It would never actually hit a single number. And so basically what that means is at none of these points is it's going to be approaching a certain value. And if the limit doesn't exist, then the function can't be continuous because there's nothing for the limit to be equal to. And therefore, for no values of x, is f continuous. I hope this sort of wishy-washy way of thinking about it was helpful, because we don't have to think about it in any extreme terms. We just have to think about it. Is there any point where the value of the function is being approached by the function as it gets closer and closer to it? And since it's constantly, quote unquote, jumping back between 0 and 1, because there's no pockets of only rational or only irrational, we know that the function is never continuous.